This video is going to walk you through the HMO case. In this case, we have responses from a very large number of HMO members, so Health Maintenance Organization members, about 25,000. So this is a huge sample. These members were asked a variety of questions. So they were asked questions about different aspects of their care. So the different aspects of the care include medical management. So how satisfied are they with the delays in getting care? So if I'm sick, can I see a doctor now? Can I get referrals? Those sorts of issues. Benefit services is all about the paperwork, dealing with the claims when I have to call in to get help. Can I get a real person to talk to me on the phone? Those sorts of issues. Cost refers to both fixed and marginal costs. So fixed being your premiums and marginal being the co-payments that you have to make when you visit the doctor. Medical quality refers to how satisfied you are with the thoroughness of treatment, quality of care that the doctors give you, these sorts of issues, all about the quality of the care you're getting. Network access is about the network offered by this HMO, so different HMOs. So within a network, they may have university hospitals or not have university hospitals. They may have certain specialists and so forth. So how satisfied are you with the network that's offered by your HMO? Finally, there's physician appointments. So this is all about the process of getting into the doctor's office. So if you're sick, you need an emergency appointment, can you get in? When you show up at the doctor's office, how long do you have to wait before you get into the doctor's examination room? Once you're in that examination room, how long do you have to wait there? So it's all about the process of seeing the doctor. Now, this case is about a resource allocation question. An HMO can't be great at all of these. So which of these dimensions should it be great at if it wants to maximize loyalty? Now, the loyalty measure we're going to use is whether or not a patient is going to recommend the plan to a friend. Let's take a quick look at the correlation matrix. And what we'll see is that all 6 of these dimensions have positive correlations with loyalty, or recommending the plan to a friend. The other thing that we note is that there are large correlations between all of the individual measures. That's an indication that multiclinearity is going to be a problem. Okay, so all of these, as we would expect, have positive relationships with loyalty, and there's multiclinearity. Let's fit a regression. So the first regression that will fit regresses loyalty on all 6 of the dimensions. I ask, do all the regression coefficients make intuitive sense? The answer is no. So let's take a look at the coefficient for physician appointments. That negative coefficient means that for every additional scale point that customers are satisfied with their ability to see the doctor, their loyalty goes down by 0.05 on the average. Now notice that that contradicts what the correlation coefficient told you. The correlation coefficient was a positive 0.33. This is an example of a sign flip, and it's one of the symptoms that we have multiclinearity. Another thing to note is that all these coefficients are very significant. The reason for this is because we have this sample of 25,000. Coefficients are just about always significant if you have a sample that size. So the significance isn't that interesting. So are the conclusions the same as with the correlations? The answer is no. Why? It's due to multiclinearity. Now let's drop one of the terms. I'm going to drop satisfaction with network access. And after I do that, let's compare what happens to medical quality. So in this first regression, the medical quality coefficient is about 0.17. So if we increase our emphasis on medical quality, and that increase results in patients having a score that's 1 unit higher, then our loyalty score should go up by about 0.17 on the average. However, in this other model, the coefficient is about 0.32, so it almost doubles because we've dropped network access. That should make you very nervous that, had we not thought to include network access on the survey, then obviously we can't include it, and we would say medical quality has an importance of 0.32. We did think to include network access, and therefore medical quality is 0.175. Well, which one is right? That's a very hard question. Are there other dimensions that we should be measuring and we just didn't think to measure them on the survey? So the point here is that you should be getting very nervous about these models. Now, let's drop physician appointments instead of dropping network access. And in that case, medical quality drops to 0.14, 0.138. So it becomes less important when we get rid of physician appointments. So we see that the importance that we ascribe to medical quality depends a lot on the other variables that happen to be in the model. So whatever we think to put on the survey is going to determine how important we think medical quality is, and that's not very desirable. So that should make you very nervous. Why does this coefficient increase or decrease when network access or physician appointments is dropped from the model? The answer is multiclinearity. It all goes back to this slide. So this slide shows biases. Now, we know that we have positive correlations between all the variables. So medical quality has a positive correlation with network access and a positive correlation with physician appointments. In the case of network access, the beta was positive, physician appointments was negative, and that's why we get the different bias. So with network access, we had an upward bias. With physician appointments, it was a downward bias. All right, well, what are we going to do about this? We clearly have a problem in that our results depend on things that they shouldn't depend on. So what do we do? Well, what I told you earlier about multiclinearity is always understand why you have multiclinearity. Now, if we go back to that slide, sorry to keep flipping around here, here's, how do we live with multiclinearity? Well, understand why you have it. Sometimes predictors are causally related, as we saw with the quality control case. In that case, we need to fit the correct model, and we're back on track. In the case of new food, we had bad luck, so we included controls, and then we were back on track. This HMO case is an example of the middle bullet, where the reason we have multiclinearity is because our X's are manifestations of some common latent construct. This is called a halo effect, and you can read about that on Wikipedia if you want. So I think what's going on here is that patients don't really parse their experience with an HMO into these discrete buckets of getting into the doctor's office, network access, medical quality, and everything. Instead, they have a kind of a general overall impression of how happy they are with the health plan. So if you ask me, for example, how happy am I in my ability to get a referral, I haven't had a referral in years, so I'll just kind of impute what my overall impressions of the health plan are on that. So really, these 6 measurements aren't 6 distinct measurements. They're all measures of some, overall satisfaction level. And because they're all, measures of the same thing with some error imposed, it's going to make it very difficult to disentangle the individual effects. And I don't think we can really answer our original question, which is how do we allocate our resources using this data set. We might want to run some controlled experiments where we manipulate some of these variables. If I were to increase the number of agents that I have so that the claims processing becomes easier. What would that do to my loyalty levels? So perhaps I could try that in certain parts of the country and not in others, and then I'd have a good controlled experiment. Maybe in certain parts of the country my network is larger or more prestigious than in others. That provides kind of a natural experiment for me to get a better assessment of this network access variable. I could also run some controlled experiments on the process of getting into the doctor's office. So that's that physician appointments variable. I would feel much more confident in the results from such experiments, whether they're designed experiments or natural experiments, than in using a regression model like this. So while the solution to the first two multi-collinearity cases were quite straightforward, it's not so straightforward in the HMO case.